breaking space news, we might be wrong about the future of the universe, and also maybe its present. Let's discuss. For the past few decades, we've had a standard model of cosmology that says the universe is expanding, and it's expanding at a faster and faster rate. We call the thing that's driving this accelerated expansion dark energy, and our best idea for what dark energy is some sort of cosmological constant. You see, while the density of things like matter will drop as the universe gets bigger because the volume is increasing, the density of dark energy remains the same. It's constant. And a lot of the evidence for this idea comes from looking at a specific type of supernova that happens when a white dwarf, the leftover core of a star, explodes. Because there is a specific mass at which that white dwarf becomes unstable and explodes, we think these supernovae all happen with the same intrinsic brightness. This makes them something called a standard candle. We know how bright they are, so when we compare them to how bright they appear to be in our sky, we can calculate their distance. However, some people think there might be a bias in the way that we're calculating these distances, specifically that we aren't correcting for the age of the stellar populations, which could impact the brightness of the supernovae. Here, the red line shows what we would expect from our standard model of cosmology, and the blue points are the supernova data before accounting for this age bias in the top panel and after accounting for it in the bottom panel. And you can see that if you apply this correction, all of a sudden we are no longer aligning with this red line, this idea of a constant dark energy. In fact, it would actually mean that the universe's expansion isn't accelerating at all. This is showing different model predictions for whether the universe's expansion is accelerating if it's in the bottom half or decelerating if it's in the top half, with right now being right in the middle. The black line is our standard model, the idea that the expansion is accelerating now and will continue to accelerate into the future forever. But it's these red and blue lines that take into account this age bias that show that the universe is actually currently decelerating and will continue to decelerate into the future, which would mean that we are completely wrong about what's going to happen to the universe. It won't expand forever, it might actually even crunch back in on itself. But these are still very early results. We need more data, we need to look at more supernova, we need to use larger surveys to try to understand if this age bias is a thing and if the data actually supports this decelerating expansion. And that's just how science works. We build our models off of the best data and ideas that we have, but as we get new information, we might have to change or update those models. I think it's too early to throw out the standard model of cosmology. We just don't have enough data yet, but there's been a lot of tests in the last couple years that suggests that change might be coming. So that's pretty cool and definitely something to keep an eye on.